I'm going to talk to you a little bit about modularization. While this session is called Best Practices, it's only parts of what I'm going to cover today. Parts of that is the use cases that you might have for a modularized app and the use that you have, as well as the use that businesses have that you work for, so how you can talk with your colleagues and your product owners about it, as well as the users, what benefit they can have from your application when you modularize it. Also, I will tell you why it's important to modularize your app in the current day and age. Also, I will talk a little bit about the support that we from Google give you for modular development within Android apps. And then I'll also cover a couple of best practices with apps that we have modularized and things that we have found. So with that, hi, I'm Ben. I used to work here in Berlin, and it's awesome to be back here. I now work for Google in the Android Developer Relations team, and that's one of the things that I spent a lot of time on. So if you want to talk with me on modularization afterwards, I'll be at the Google booth. So let's get started. So let's take a look at three key metrics for the beginning. So one of them is space, the second one is time, and then there's cost. So let's see how they're related. Out of 10 Android devices, 3 of them have less than 1 gigabyte of free internal space available. And that is a problem that's globally. That's not just for entry-level devices, it's also for high-end devices. Users that have entry-level devices usually fill it up fairly quickly with applications, whereas users of high-end devices fill it up with media and things of the like. And everybody is likely to uninstall applications if they're quite big. Second metric we want to take a look at is time. Time, in that case, is the time that it takes to download your application from the Play Store. If you have a big application, so a larger app obviously takes longer than a smaller app to download. So many users of many apps don't have a high-quality, high-speed internet connection, so it takes a lot of time for them to download it. Sometimes users just lose patience, or when they see that an app takes a long time to download, simply just cancel the installation. Also, well, a smaller app downloads faster, so if they lose connection on the way, that means that the app is more likely to be downloaded already. A third metric is cost. Yeah, data costs money. In some places, data costs a lot more than in other places, so it's not ubiquitous available. Wi-Fi is another thing, can be metered, could be unmetered, but sometimes sometimes users have the problem that they actually have to pay for every byte they download. So this is why you should be aware of these 3 metrics. They have one thing in common that I already hinted at a couple of times, and that's app size. So the bigger your app, the more space it takes up on the device, the more time it takes to download, the more it costs your user to actually download the app. So there has to be quite a benefit for your users to download a large app. We analyzed the data of this, and for every 3 megabytes that you reduce your file size, the user is about 1% more likely to install your application. So every feature that you add has the possibility to decrease the download size if you just keep on adding them on and on and on. So with that, let's take a look at how this was, how you installed application, how you built application in the past. Firstly, well, you know the early days of Android, we came up with the Android packaging format, the APKs. They get installed on the device, and everything is in one single file. So the resources, manifest files, and everything the likes, as well as code and some meta information about the package. This is perfect for monolithic deployment and just turned about 10 years old. So it's great. Happy birthday to them. I'm very happy that this format is there because, well, that allows us to create applications, that allows us to download them to devices and to publish them. But along the time, we figured that the average APK size over time just increased. Well, this happened because you added new features, you added new things. We, on the one hand, added possibilities for you to decrease file size. But as you can see in this graph, this only helped so much. So what we did is we introduced better compression, we introduced delta downloads, vector drawables, guiding on reducing your file size of your application. And you can see the bumps in there. So it helped, but in the long run, it didn't really help to stop the APKs that we're seeing from growing. So we took a step back and thought about how we can help you as developers to get higher installs and have better ways to make your app available to users. So we came up with the Android app bundle. The Android app bundle essentially is a new publishing format that includes all the data that you can ship to your users, and I'll go in depth in that in a second. The key thing that this does is it allows an application, by simply switching over to it, to save a massive amount of file size by only installing parts of the application that the user actually will use. We saw this for a couple of Google apps that we use this internally with. There's file size savings of up to 63%. By simply switching over to app bundle. So all you have to do is, instead of building an APK, is you build an app bundle and upload that to the Play Store. Let's take a look at the internals a little bit. So the Android app bundle covers a couple of folders. Firstly, the base folder, which contains your base application. And if you simply switch over to app bundles, this is what you get. Everything is encapsulated in that app bundle, and the bundle tool, which you can use locally or on the Play Store, unpacks that into separate APKs. Cool thing about this is these separate APKs enable something called dynamic delivery. So dynamic delivery is the way that we make sure that only the things that the user actually will see are downloaded and installed on the user's device. Usually your application has a couple of resources like this. Maybe it has also some native code in there. And for a monolithic application, what would happen is everything would get downloaded. But many users only will actually see part that is relevant to their display density as well as to their CPU architecture. Everything else is dormant and will, in most cases, not be used by any user. So through dynamic delivery and through splitting it up into different APKs, this is what we get. We get a master APK that contains most of the code and resources that's shared, outside of the things that you can strip out. This is simplified. There's also languages and other things that I didn't mention here, but just for simplicity of understanding, this is how it works. And what then happens from the Play Store is depending on the device that the user has, the APKs get selected and shipped to the user's device. So that enables massive file size savings, depending on which kind of app you have, depending on the drawables you have, depending on the way that whether you have a lot of libraries in there that are using native code or not. But already for many apps, we've seen a massive file size savings. So it makes a lot of sense to switch over to app bundle just for this, and the amount of time it takes to do that is minimal compared to the savings that you get out of it. So on top of this, we created dynamic feature modules. Dynamic feature modules work down to Android Lollipop, which currently is at about 90% of market share. So if you target application down to Lollipop, then you have a market share of potentially 90% of Android users that is out there. But even for platforms that are targeting older versions, you can still use dynamic feature modules and then fuse them into one single APK, and the users will still get one APK that they can download. But for everybody else, for the ever-increasing number of users that are targeting L and above, having L and above on their devices, they will be able to make use of the dynamic feature modules that you have. How this works is essentially in the same app bundle, there's just a couple of new folders which contain similar information to the base, and those can be unpacked in a similar way, which gives you even more APK. I know there was multi-APK in the past, but they were quite a pain to manage, and you had to do different version codes and different other things to make sure that they all were set up correctly. So what this gives you is out of the box. Once the app bundle is uploaded, Play Store or bundle tool in that case makes sure that everything that the user needs will be installed on their devices. So without you having to figure out which version has to go where, and you don't have to set manifest flags for anything else in there, because that's done by tooling system automatically. So that's quite cool. With that, there's a couple of ways to do app deployment. So when we talk about app deployment, there is two main key things. So there's monolithic app deployment, which is if you have a modularized app that has several libraries. It's already a modularized app, but you still get monolithic deployment, which means you have one APK that gets installed on the user's device. It is, in fact, already a good step forward to modular deployment. Modular deployment is if you switch it all over to dynamic feature modules, you got the possibility to install the one base APK plus a set of each and every single APK that you have on top of this. So for a modularized app, what you get, be it with libraries, be it with dynamic feature modules, is build time improvements. And I'll get to that in a moment on a couple of numbers on how much we saved for Plaid, the sample app that we used for that. And also your code base will be more maintainable. Your code base will be more maintainable because each module, which is a separate compilation unit, enforces you to have the code in there separated. So each of those modules can have its own API, so it's really hard compared to just having packages to have dependencies that you don't want in between them. So you have to direct your dependency graph, and you have to make sure that the things that you expose actually are intentionally exposed. This also makes it more maintainable from a development point of view, because you have those modules that you can then hand off to separate teams, or separate people can be owners of that. And it's easy to see if somebody adds stuff in that module that shouldn't be in there. And that clear code ownership from the developer point of view is, in my eyes, a thing that really helps to increase code quality over time. So I talked a little bit about dependencies here. So what works here is you've got the app module, and the app module depends on the library. And if you separate code out into a library, like I said, you're already modularizing. It's cool. But if you want to make use of dynamic feature modules, they sit on top of the application. So they depend on the application. And well, if you want to know what stage you're in, if you use the dynamic feature module, then this is a dynamic feature. If you use the application module, it's the application, and the library underneath is the library module. And that's the easiest way to spot which ones you're actually looking at. And in many cases, it's fairly easy. You can also depend on the part where the part how things can depend on one another is that the dynamic feature module can also depend on libraries directly, so you don't have to go all the way through the application in order to have a library, but you can package a library directly with a feature module, and I'll come to that in a second as well. So with all this foundation and all this base information around this, let me talk a little bit about how to actually modularize an app. So what we did is we took all this and decided to modularize an application that we have out there. It's one of our hero samples. It's called Plaid, which recently moved to the official Android account. We used it for a lot of things through time. Part of it is for material design, for animations and transitions. We used it for dark theme. We used it for modularization and also dependency injection, and a couple of things that we showed with us over time. If you haven't looked at it, it's definitely worth playing around with it, seeing what we do in there. It's under active development. We every now and then open issues that are up for grabs. That means that you, as part of the extended community, are invited to contribute to it. And if you have feature requests and things like, we'll open that up at some point in the future as well. So before we started actually modularizing it, we just switched over to app bundles, and it gave us 64% of file size savings. So the app is smaller by 64%. That is because we do have a native library that is in a couple of APIs that we, with the CPU architectures that we only have to ship one of them. Resources and drawables are not the biggest part here, because we use vector drawables a lot, and those vector drawables are density agnostic. So how did we approach it afterwards? So we took a look at features that we could modularize. The features that we could modularize were our user-facing features. I'll tell you a bit about them in a moment. And we then restructured code and resources to make sure that it fits the approach that we want to take for those modules. And then we created and populated dynamic feature modules. So let's go through those steps. Every app has code, resources, dependencies, and drawables to some extent. And that is true before the app is modularized as well as after it's modularized. What we firstly did is we took a look at our code, and we started to figure out how do we want to break this down to dynamic feature modules. What we did is we, on a package level, started structuring it in a way that it's packaged by feature. So each feature got its own package, and all the code that was relevant to that was put in that. So we had code by layers, and then we simply sliced it by features as well, put the code from A to B. Well, it was not that simple all the time, because there's dependencies that are in between a couple of things, and some things can't be easily untangled, so that took a while, but it worked in the end. So there's a couple of things that are still not 100% done, which is fair. It's a legacy app that we were dealing with. It's not an app that is completely new. So you might have the same issue with that, but it's fair. It's fine and fair enough to have a couple of these spots in an application that take longer than others. From there, once we had done this, we took a look at our resources. And I know that Nick and Chris just talked a lot about resources, and Chris shared a couple of tips on how resources should be structured and can be structured. I would go even further, especially in modularization. What you should do is you should not just have a strings file, for example, but you should have strings based on module names. So if you have an about module, you want to make a strings file which is called about strings. For the base module, one that's called base strings, and put all the strings that are relevant in there. In the end, those will live in the dynamic feature module, but for the first step, while you're getting there, it's still fair to have everything into this one rest folder in separate files. The same also is for attributes, layouts, and themes, and everything likes. We gave it a prefix just to make it easy to spot where it's at, and move it into those, move the corresponding resources into those files. Also, dependencies is one of the things that I'll go into a second, how we actually structured it. Dependencies, we broke those out into the feature modules, and we made sure that dependencies are only scoped to where they are needed. Some of those have a wider scope, some of those have a narrow scope. So with all this, what we started is doing the first dynamic feature module. And that first dynamic feature module was the simplest module that we had around, which was our about module. It didn't have any dependencies with other modules other than the home screen being able to start it through a menu. So there was no internet connectivity needed. There's nothing in there that makes it dependent on the other modules that are available. So we moved all the code, all the resources, all the dependencies over to this module. With Android Studio, we then created the new module itself, which pre-populates it, adds the dependencies on the base module, on the base application module. We have to set the package name and the module name, which is being used to identify the module on the Android on the Android level, and we were ready to go. There's one thing that I found a bit tricky I want to share is, well, tricky is not the right word maybe, but is tricky to read. Which is if you have imports from multiple modules after you have modularized your application. One of them is you have, in that case, from the about activity, you import the R file from the about activity, that's from the about module, that's fine. You can easily just call it with R layout activity about. It's cool, but if you have imports from other modules, you get the fully qualified import name, which can be really tricky to read over time, and it makes code reviews a bit trickier. Luckily, with Kotlin, you can alias imports. So that means you can just say instead of the fully qualified name, you import that as appr, and so you still can shorten all that down to appr instead of having the fully qualified app name, fully qualified import name, and that makes it easier to read, and it's still very maintainable for your whole application. So after we finished modularizing the application in this way, we managed to bring our build time down from 3 minutes to 1 minute. That was on this machine for a clean build. So I checked out the code before we started modularizing, I checked out the code after we modularized, and I did a clean build, and it was a lot faster afterwards. Still, same stuff that we did. We didn't remove any features. We didn't remove any stuff there. So we looked into why that is. And the build time improvements mainly are because of parallelization. So Gradle has a possibility to run builds in parallel if they are decoupled enough. So that means that you can't run everything in parallel, but it means that you don't have to run everything one after another, But builds can be run next to one another. As you can see, a couple of those threads might be idle at times, a couple of those threads might be doing something. They're all at different stages. Another cool thing about this is this already helps for clean builds, but in an incremental build, what this can do is you can, something's wrong with my animations here, but what you can do is instead of building everything at the same time, the build system can skip building the things that weren't changed, skip building the things that don't need to be rebuilt, and sometimes you only have to rebuild a single module that then gets packaged into the bundle. So that can improve your build speed and build time turnaround a lot more as well. So all of this is cool, and there's a couple of things that you can do in the future with it that we haven't done with Plaid. We're quite happy with where we're at the moment. But I know that on-demand delivery is a thing that people are asking about. How does it work? And with I/O this year, it came out of beta, so everybody can create their own application with on-demand modules. On-demand modules essentially are modules that are dynamic feature modules that are not installed at the initial installation time. So let's take a look at a sample app, the recipe finder, where you have the possibility to install a feature once the app is downloaded. So that means that initially the app might be downloaded, and the feature isn't there yet. Once the user clicks on this button, you check whether the module is there. If it's not there, you download and install it. That works quite well for smallish features. For larger features, it works as well. But what happens sometimes is that your users might be warned by the Play Store that they're about to download a larger module. That is in order to make sure that we value the data network that the user has, as well as battery, as well as the file size constraints that they might have. There is no clear rule on when it shows up, but it's essentially its amount of data over time. So if you try and download a lot of modules very quickly, then this might show up. It's fine. You just might want to warn the user. You've got a callback for this as well, so it's fairly straightforward to say, user, if this happens, you're about to download a large module, you might see this. If you want it to be downloaded, then yeah, you have to click the download button. So with this application that we just looked at, there's a couple of modules that it is modularized into. There's an onboarding screen, there's a recipes screen, which we just saw. There's also the My Recipes, which is an on-demand feature module. And there's a premium feature that's, so let's take a look at how this app looks when the app is initially installed. What we have is we have the onboarding screen as well as the recipe screen. Everything else is not installed immediately. So once the user finishes the onboarding, what you as a developer can do, you can remove it, because the user might not want to see it again. If the user then wants to see it again, you can re-download it. But I know that there's onboarding screens with videos or overlays or things that actually essentially cost a lot of storage on device. While you still have to download them in the first place, you can then uninstall them. And I think that's a very nifty feature in order to get rid of things that you don't want your users to have permanently on device. Then the next step would be the user discovers the feature to add their own recipes, so they can download that. And once the user decides, in that case, through an in-app purchase, to purchase premium, you can download that feature as well. So you can easily install and uninstall features as you like. There's just one caveat to this. If you know that you uninstall a couple of the features, you want to check whether the feature is actually available before you try and launch into that feature, because, well, if you launch somewhere there is nothing there, worst case is your app might crash. So how does this work from the manifest perspective? What you have to do is, in the Android manifest, you declare the distribution tag. And in that case, what is really relevant is that you set it as on-demand true. If the feature is set as on-demand true, the Play Store does not download and install it when the user downloads the application. As long as this is set to false, all the modules will be downloaded. So this is from within one of those modules that is set as on-demand. From checking how you can download the module is the Play Core library is the one library that you want to use. It has a couple of features next to dynamic features that you can use. That also allows installation of languages and a couple of other things. And downloading a feature is pretty straightforward. You create a request that can chain multiple modules that you want to download, and then you start the installation. There's also this tongue twister of a listener, the split install state updated listener, that has a couple of states that you might want to implement. Most of those states are on the happy path. So usually when you start from pending, you go through the downloaded states, and the module has been installed. That is where you want your users to be in the end. But sometimes your users might cancel, or for whatever reason, the download might fail. So those states are as relevant as this. And like I said, you have a callback for the screen, the screen that when you download a lot of data in the first place, that allows you to check whether the confirmation is required before you actually can download. So that is the other one that you definitely have to implement. Well, you might only have to implement that one for everything else to work, but if you want to show something around the status, what's going on, and if you want to notify the user, which is a good idea, you want to implement the other ones as well. Well, on-demand delivery is one of the ways that you can, on top of app bundles and dynamic feature modules, can install modules. Another way is using instant delivery. Instant delivery, called Android Instant Apps, called Google Play Instant, in the way that it is delivered through the Google Play Store, has been around for a while. Actually, it's based on the same technology that we use for the Android app bundle and dynamic feature modules. But over time, we saw that there's ways that we can do this better, so we made it better. So, for example, the Android Dev Summit app that we used last year has a Try Now button. The Try Now button essentially downloads the application and runs it without the user having to permanently install it. So in my eyes, the conference app is a great example for exactly this, because it's an app that you have mainly for those 2, 3, 4 days that your conference runs, and afterwards you're very likely to uninstall it, or maybe you forget about it, and next year there's an update to it, which is cool if you have enough storage space. I know that some of you have been working with Instant Apps before, so can I get a show of hand who worked with Instant Apps before we made the change to the new format? All right. Let me reassure you that now it's a lot easier. So what you have to do is you have to add the dist instant tag to the dynamic feature module or your base module, set that to true, and it's also available as an instant app. As long as your application or the parts of the application that you want to download are less than 10 megabytes, that works straight out of the box. If it's less than 4 megabytes, then your app is eligible to show up in search results as well as in ads, for example. So if you have an ad that's running in another application or in a browser, your app can show up there and the user can launch it directly from there. And all with that one flag. At I/O this year, we introduced another way that you can install your application to deliver the application to users, and that is conditional delivery. That's the first time that we enabled this. So this allows you to install and download and install modules based on certain conditions. One of those conditions could be device features. So you want to make sure that the device that the user is running has a camera, but you don't want to create a separate application if the user does not have camera. But only this feature is relevant for the users that have camera. So you can just say, this module is only downloaded to those users. Cool thing again, the users that don't have a camera don't need to get this module, don't need to have the stale code and the resources on their devices. Same thing with values, so with min SDK numbers. So that means you don't have to create multiple applications for different minimum SDK versions, but you can create one single application for this, and you can add some features that are only relevant for users that have a certain SDK, min SDK version. And the one thing that's the first time we're doing this in this level, in this granularity as well, is possibility to exclude or include countries that a module is being delivered to. So you can say this module is only being delivered to a certain set of countries, or on the other hand, you can say this module is not delivered to certain countries either. So if you have an application that is relevant to multiple countries, but some of those features are relevant only to one of those countries, so you can say this feature is only being downloaded by this. And it's just straightforward country codes, how you enable or disable them. And you say this exclude in order to say whether it's included or excluded with a simple Boolean flag. Another thing that we introduced at I/O this year, which I think is pretty cool, is internal app sharing. Who of you has used internal app sharing? Cool. Well, I hope that after this, a couple of more will use it, because in my eyes, it's an amazing feature. One of the things that it does is so you can upload to the Play Store with that package name based on what the owner of the account says. So if your team wants to upload only to the internal app sharing track, they don't have to be owner on the Play console. I know that there's a lot of companies that gate this quite well for their own policies and reasons, but you can only upload to this track if your account owner says this is okay, but you can't do anything else. You can literally upload to there, then you get a link, and then you can download this application from there. A second cool thing about it is it doesn't have to be signed with the production key. So that means that the application can just be uploaded as a debuggable application as well. It's not a release application. So I see one blown mind with this. So let me go a bit further in depth with this. The really cool thing about this is you can upload an app to the Play Store, you can request a download, and you can attach a debugger to an application that you get from the Play Store. And you can test all your listener implementations and all the checks that you made for dynamic feature modules on demand delivery directly within your IDE with an app that you get served from the Play Store without any hassle around this. So it's the real deal. This is what your users will see and what your users will get. I know this was possible with the test track, alpha track, and all those before. But the next cool thing is there's no version code enforcement. So you don't have to increment the version code over time. So literally, you can add this to your build script and say, I want to publish to the Play Store in order to test this. So you upload it, you get the link, you launch the activity, you launch the application from there, everything is fine, and you don't have to increment the version code over time. So there's no price to pay for on that front as well. One more thing that I wanted to cover is testing. Testing has been talked about over the years, has luckily improved quite a lot, and we had a couple of talks about this at this conference as well. So if you have tests, what you usually have is they're in Android test folder or in the test folder. Well, for instant apps, for dynamic feature modules, we kept it the same way. So all you have to do is you can put the test that you write into the same folder structure, but just in the dynamic feature module itself. Cool thing about this is that your tests also can run in parallel. So you launch your unit tests, they all run at the same time. Nice, cool, faster than before because they're all run in parallel. But when it comes to the connected Android tests, so to your instrumentation tests, your espresso tests and the like, there is a bit of weird things going on. So they failed for me quite a bit when I did this for Plaid, and I was very confused about why and what happened. So essentially what happened is, yeah, it got me confused. Then I took a look, and I was like, okay, good, what's the problem here? It was not the same error message all the time. And of those 4 modules that we had at the time, they were failing at various stages. So sometimes the test runners were stale, nothing happened anymore. Sometimes we did get responses, and sometimes the tests succeeded. It was very flaky in a way that I couldn't really deal with. So what happened is the first module got installed, that was finished, it got installed, started to run. Then the second one finished the build, got installed. Well, but before an instrumentation test is installed, what happens is the old instrumentation test for the package name being uninstalled. But the test runner isn't stopped. So that means the second module is like, cool, I've got all the things that I can do, I can run. But the first one is gone, but the test runner is still looking for responses from the first module. Same thing happens with all the other modules over time, and since they don't all compile and finish at the same time, that was a bit problematic to see what the actual problem there was. But once I saw it, I found out that it's fairly straightforward to fix this by just saying we're not using parallel compilation at all. But there is a problem with that, and that means that we increase our build time, increase our test time, and that's not really cool. So what we did with this is easiest way is to just run it one after another if you want to keep the tests parallel, the build for everything else parallel. So everything builds in parallel, so you can just run a couple of commands. Or if you want to run one single command, you just say --no parallel on the connected Android tests when you run those. So everything else is still in parallel. You still have all the benefits and all the gains, but your tests actually won't cause you a lot of headache. So that's why I wanted to share it. It cost me way too much time. So I talked a little bit about dependencies. Dependencies matter in general already, but for dynamic feature modules and for a modularized app, dependencies are one key element that you have to take a look at, and you have to understand how to do dependencies, not dependency injection, but dependencies between modules in your application. Like I said, we have a directed dependency graph where a library is dependent on the application, and the application is, the application is dependent on the library, and the feature module is dependent on the application. That is the base graph that you always will have. Obviously, there's libraries that can be part of a feature module, but in general, your graph is directed in this direction. So the library always is on the bottom layer, the application is somewhere in between, and the dynamic feature module is depending on the application itself. So let's take a look at a couple of scenarios. So we have an application that is depending on a library using the API keyword in Gradle. What happens is that the application and the library is bundled together in one single APK, and then the feature module on top of that depends on the application, and through the API keyword that you used in the application for the library, the feature module can transitively depend on the library that you have underneath. While this is really cool, it might have some side effects that you don't want to have. So it can increase build time if you make changes to the library. The whole tree has to be rebuilt. You don't want to do this all the time. Also, you don't want to expose everything from library, but maybe just some parts. So what you can do in that case is you can just say, again, you use implementation instead of the API keyword. Main problem here is that if you have implementation of app, the feature still can depend on the app and can access everything from app. But if you don't expose the dependencies directly, there is no way for the feature module to access part of the library, unless you just say, hey, the library also, the feature module also implements that, has an implementation of that library. This doesn't mean that the feature has a second copy of the library. It means the library is in the class path and is provided by the app itself. So that's quite handy, but sometimes you might want to package the library directly with the feature module as well. So that would work in a way that the feature module has the library and is packaged in there. So the base module and the application module is smaller than it was before. So if you have a library that is in an on-demand feature, it means that your application download is smaller. That means that your users will are more likely to download the application in the first place. But then you want to also depend on the module, on the library sometimes from the application itself. And that's where compile only comes in. Compile only is a keyword for Gradle that works for non-Android modules. So if you have something that has COM Android, for example, library, application, or dynamic feature, you unfortunately can't use that at the moment. But if you have a Kotlin plugin, if you use a Kotlin plugin for the library that you want to provide, you can just say compile only. And compile only is essentially an IOU to the compiler, where you promise the compiler that if you can write the code from this library, you will make sure that the library is there at the time it runs. And you don't want to make your compiler unhappy. So you don't want to make sure that you don't want to make your compiler, well, regret that that it trusted you, because then you will regret that you misled the compiler by your app being crashing. So how does it work? Just a little bit more clarifying this. So the library doesn't use the any of the COM Android Gradle plugin. The feature provides a library and packages with itself, so all the code is in there, all the resources are in there, and the app checks for code availability. And that is just a simple gate. So you literally check, is the feature installed, can I access the code? Yep, then execute that code. If not, then first download, then execute. But there's also other ways with intermodule communication. It is a bit of a pet peeve of mine and a couple of colleagues to figure out fun ways around this. So essentially, the feature module can access the application, and that can access a library in general. That's the way the graph works. But barking up that tree on the other way around is not straightforward possible by the rules of that directed dependency graph. So let me show you the one weird trick to intermodule communication. And like I said, it's not one, but maybe a couple, and it's actually not weird, but it's just a couple of tricks how you can communicate from one module to another, or from a base module up to another module. And it is actually required, because how do you launch an activity if it's in a dynamic feature module from the base module? Well, how do you do that? Easy as that. You just give it an URL or a URI, and you launch the activity in the same intent that you already did. Or if you don't have URLs, what you do is you pass it a fully qualified class name, which is also known as a reflection call. Nobody frowns away from that. I'm very happy to hear this. This won't give you any performance penalty, because that's what the Android framework does underneath anyways. So it's the same thing, but you just are explicit about it. For Plaid, what we did is we put all those fully qualified class names in a single point, in a single class, and that makes it easier and makes it stable for us. We don't have to rewrite this all over time. There's no typos. There's no probability of us to causing trouble there in one part of the app and not all the other parts of the app. So if it's broken for everybody and not just for one part of the app. So centralizing this in the base module makes a lot of sense. But it also works, for example, for fragments. There is no performance penalty for that anyways, because that's the way that a fragment gets instantiated as well from the framework. Works also for anything else, like Dagger classes or some other classes that you might have. If you want to access code from this class in the base module, what you can do is you can have a interface in the base module that you then instantiate later on. I'll show you how that works. So you have your, well, I don't show you this one, sorry. So essentially what you do is you have the interface, and you instantiate the class. Oh, actually I did. Sorry, as my interface. That's what you say here. So you cast it to that interface, and because of that interface being in the base module, That means that you can call anything that is from that interface, from the base module, on the instantiated class. So that allows you to have the code and the actual implementation in the dynamic feature module, having one reflection call, and from there on being able to maneuver and navigate using that interface itself. Also gives you the possibility to have multiple implementations of a class using the interfaces. And that's quite fancy, and I really enjoy that part as well. Yeah, another thing is compile only that I just mentioned, and I showed you how that works. So if you have a library that's not an Android library at the moment, you can just use it as compile only. You can call it directly from the base module itself. So for inter-module communication, one of the things that you want to make sure is that the code is available using the Play Core API. You just ask, is the feature module installed? If yes, then let's go ahead. And on the other hand, if you have possibility to modularize your application to the point where you have compile-only modules, use it where possible, because that makes your life and the way that you write your application a whole lot easier and a whole lot more stable. So when it comes to instantiating components, there's one way for manifest entries, which you can use fully qualified class names, or reflection, or the URLs or URIs. For non-manifest entries, you can use reflection as well, or discovery through a couple of ways. I'll show you how that works in a moment. Or there's also a class that you can use that's called a service loader. That's part of the APIs for a long time. And you only want to use that if you use R8 in 1.5 and above or 1.6 and above, because before that there was essentially it caused a lot more overhead and it made everything a bit slower. So service loaders are only recommended from using the newest version of R8. If you want to take a look at it, it's quite cool the way it works. Soon, we'll support that even better with dynamic feature navigation. So I know that a lot of you are using navigation component, and I had a lot of questions here about the way that you can navigate between dynamic feature module or in dynamic feature modules and using the navigation library, especially on on-demand modules. And yes, we're working on this. And also, as you saw, that listener has a couple of functions that you want to implement. We're creating a KTX for this as well, which is coming soon in order to make the life for you a lot easier there as well. But don't just listen to me, read all the things that we can do, that we did here. If you want to, we have quite a bit around it available. So firstly, Plaid is a great sample for it that we are working on over time. If you have questions on it, feel free to shoot me a message on Twitter, or if you have an issue that you find, open a bug there. We're very happy to take a look at it, and it's quite a few of us that work on it. We wrote a bit on it on a couple of different levels. So one of them is the way that you can access dynamic feature modules. That's the last part that I just talked about. There's also a sample for this available. I wrote about the modularization process of Plaid more in depth, and also the way that we use Dagger in this modularized application. And also, there is documentation available for all this. So for the Android app bundle, for instant apps, as well as a couple of samples that you want to take a look at that are base API samples for dynamic features, dynamic code loading, which goes along with the article that I just mentioned, and also the instant app samples have been converted to use Android app bundle. And with that, thank you very much, and I'll be in the QA booth.